Welcome to Sigest, your fortnightly serving of digestible science from plant and food research.
Kia ora and welcome to Sigest. I'm your host today, Julie Blommaert, and I'll be talking to Dr. Suzy Black about open ocean aquaculture. Suzy has been with Plant and Food Research since before it was called Plant and Food Research. She started out working summer jobs here while studying, and now she's a science team leader for the physiology and post-harvest team within seafood production. And welcome, Suzy. Thanks so much for agreeing to be on Sigest.
You're welcome. Not a problem.
I hear you've been with Plant and Food for quite some time.
Yes, I started here with crop and food research in the end of 1994. It was at the end of my first year at university.
Yeah.
And I was doing the rounds and trying to find a holiday job, and I came into crop and food and they needed someone to clean their fish tanks for the summer, so I've been here ever since.
Yeah, fair enough. Did that align with what you were studying at the time?
Yes, I was studying zoology at University of Canterbury, and so I've always been keen on fish, and so it was a perfect fit for me.
Yeah, it really sounds like it. What originally got you interested in fish?
I guess I've grown up in Nelson, and my family's got a batch down in the Marlborough Sounds at Kiwi Bay, and so I've spent all my childhood out on the water, catching fish, snorkeling, swimming. Fish has been a pretty big part of my life.
Yeah. Do you have a favourite spot to go fishing or swimming, or do you want to keep that secret?
Sort of down around Durban Island. There's some pretty neat places down around there, but blue cod's probably my favourite fish. So
yeah, pretty solid choice.
Yes, absolutely.
Yeah, and then from there, how did you get interested into aquaculture?
So through working at Crop and Food, so I spent all my university holidays at Crop and Food, and so I was exposed to aquaculture there because when I started we were doing work around the aquatic anaesthetic AquaS, and so that's an anaesthetic for utilising in aquaculture, so particularly New Zealand salmon aquaculture at the time.
Yeah.
And so I had a fairly good introduction to it then, going out to the salmon farms and seeing the operations out there. So that's actually where it first started.
Yeah.
Then sort of dipped back into wild fishing for quite a chunk of my career, and then have come back into aquaculture. So I've sort of gone full circle from where I first started. But I also was able to do my honours project here at Crop and Food. So I actually did that on yellow-eyed mullet, which was quite interesting.
I didn't even know that we'd worked with those.
Oh, absolutely. That was right at the early stage, was that first introduction to fish welfare, animal welfare, and looking after your animals, and that is the be-all and end-all. If you look after your animals, they will look after you. Yeah. And so being nice to your animals, handling them well, they have a good death, it's quick, they're not struggling, and that was my introduction to looking after fish. And so moving on from there, I was also lucky enough to do my PhD here at Plant and Food, back then Crop and Food, basically focused on how do you keep fish fillets fresher for longer. So more of a deep dive into that post-harvest space of fish muscle, and getting down into the nitty-gritty of how does the tissue break down, and how do you slow the tissue from breaking down after it's died. And so
that sounds like it could be potentially smelly work at times.
If you get it wrong and you store them at the wrong temperature, yes.
Yeah.
There's certain things of seafood I can't eat anymore because it wasn't just based on fish. We did some shellfish as well. And then during my PhD, I wasn't only just doing my PhD research. I was often roped into other things as well. And so all sorts of other experiments, which was great fun, really great experience. And so coming out of my PhD, then started looking at hoki quality. That's something that my old boss, Alistair Jarrett, had looked at many years before that. And it was something that he just had never put to bed. It was still something nagging at him, and the quality wasn't great. And so we had another look at hoki quality. That was in the mid-2000s. And we spent quite a lot of time on that, looking to improve hoki quality, and that's where Alistair developed some cameras that could go down into the trawl, and you could actually see where damage was occurring as the fish were being captured. And that little nugget of video sort of then developed into the precision seafood harvesting program, which was where we revolutionised trawl fishing to catch fish in a better way, so that they actually maintain their energy and they could maintain control throughout the capture process. And then from there, during that, then we had another project underway looking at, we can try and improve the quality of all the fish we catch, but how do we increase the amount of fish that we can harvest? And so that was looking at increasing production. And so in a roundabout way, we got to a point where we thought, well, hang on a minute, why can't we actually grow fish out in the wild, but can we actually move the fish around? And so this is where we came to sort of the mobile aquaculture piece, and that's sort of where we are now.
Cool. It sounds like there's a lot of little threads to pick at, and I'm sure we could talk about all of this for hours and hours.
Yeah.
But I think there's sort of a theme here that you've mentioned about, I guess, caring about the fish and their welfare and how they're doing. Is that sort of the main thing that has brought you through all of this work?
Absolutely.
And ties it all together?
As you picked up, that's been the theme running through all of our work, is how can the fish be at its best, whether that's after it's dead, and how can you maintain the quality of that fish through to the capture process and the wild fishery, through to aquaculture. What's the best production system? What's the best harvesting system for that as well? So and trying to look at it from the fish's point of view, not developing something and then go, oh, can we fit a fish to that? Looking at it the other way around. So what does the fish need? And then building a process or structure around it.
Yeah, that seems like a really cool guiding principle to kind of go with. Do you want to give us sort of an overview of the main parts of the program that you're working on now and how that relates to
absolutely. So the research program we're looking at the moment, we've called it Reimagining Aquaculture, and it's based around the idea of getting away from conventional aquaculture, which is stuck in one place. So you're always at the mercy of the elements year round. So whether it's too cold or too hot, there's not that much time of the year where things are just right. So can you actually come up with a system where the fish are in the right place all of the time for them? So it's the best water temperature for them, the best water quality, all those conditions are great. And this is where we came up with a mobile idea for aquaculture. And so the key things in that program are, again, coming back to the fish, understanding your fish. We've got a couple of species that we're looking at there. So one's Chinook salmon, or our king salmon here in New Zealand, and also the New Zealand snapper as exemplar species. And so we're wanting to understand, okay, well, if we're going to be out in the open ocean, what are the conditions that these fish like to be in? What are the flow rates they like to be in? You don't want to be having your fish in a flow rate that's just too fast for them, because they'll tire, and that's not going to be good for them. They're not going to put on weight and grow very well. But also understanding the temperatures they like as well. We've had a couple of PhD students looking at that, which has been really great. And then from there we take that understanding of their physiological needs and then build an enclosure around them, so that we can create an environment that is going to support those physiological needs, that we can create the right flow environment, that there's low turbulence but the flow is at the right speed. And so we understand the fish, we build the right structure for them, and then we've got to have the right monitoring and support systems for them to be able to grow really, really well. If we're going to be out, way beyond where we can see out off the horizon, we have to understand how happy our fish are, if they're growing really well, they're healthy, and that they're resilient. And so we have to develop these monitoring and support systems for them while they're out there. So that's a pretty big chunk as well. And another aspect of the program, and it's kind of relatively New Zealand specific, but there are some parallels with overseas, is the New Zealand context. There are a number of, and we'll get onto this later, is the legal and regulatory piece here in New Zealand is quite interesting. And so that's been another big piece for us as well. And also for Māori, it's a huge piece as a part of this program as well, and looking at how this type of technology and mobile technology, how that is an opportunity for Māori and New Zealand. So there's sort of, those four key areas: the fish enclosure, the support and monitoring that you need for them in that New Zealand context, the regulatory piece, but also the Māori side of things as well.
Cool. That definitely sounds like a lot of moving parts there.
There's a lot of moving parts.
Do you want to chat about some of the bigger challenges that are associated with this for you?
Yeah, I guess the big challenge is actually just being able to do stuff out in the water. That is our main challenge. I have full confidence. We've got a fabulous team of people working on this, absolutely fantastic. Great collaborators here and overseas. And I have no doubt that the technical side of things, it's all completely doable. I fundamentally believe that, and we've got the right people to do that. But actually being able to be out on the water and being able to test these things is not easy. It's really hard, and it's really expensive as well. And so the single biggest challenge is actually just being allowed to trial these structures out in the water with fish inside of them. We can trial things out there without fish inside them, but we need an aquaculture consent to be able to trial the structures with fish inside of them. And I guess you could say, that was a bit of an oversight by you guys when you came up with this. And it's like, well, we knew we had to get a resource consent, but we did not know how difficult and drawn out the process would be. A mobile idea, yep, sounds great. And you think, yeah, great, it's really cool. But when you actually start getting into, well, how would we actually do this? How would this actually happen in the New Zealand context? This kind of concept sits squarely between the Fisheries Act and also the Aquaculture Act. So there's not an existing framework in our legal and regulatory system that supports this research. So we're paving the way in a way, because we're doing a piece of work right now looking at how we could enable experimental research out in the ocean, whether it's experimental aquaculture or other things. How could that be enabled? But also looking at other options within the New Zealand framework that could help enable this type of aquaculture to happen.
That definitely sounds like a big piece of work you've bitten off there.
Yeah, it is. And everyone says, so why are you doing that in a science program? And it's like, well, it's the major part of how this could be implemented. So we can't ignore it, because we could do all the science we liked, but if there's no implementation pathway, well, you're stuck.
Yeah.
There is no more.
Yeah, exactly.
So
there's not much point putting in so much science if you can't then roll it out in the real world.
Exactly. And there's some amazing people out there in this space that are just very keen to see this type of thing happen. Yeah. And only, too pleased to help out. Nut out these are quite difficult concepts to talk through, think through, and come up with different options. I wouldn't say it's the really enjoyable part of the science program, but it's a different piece to what I'm used to, and I find that quite neat.
Did you think that you'd end up working in sort of the regulatory and legal sort of framework space?
And let's face it, I just skirt around the edges and kind of entertained by all that encompasses that, but the experts that are involved, they are the brains behind this. They really are. They know the different acts inside and out, and I can see them. They will be the architects of whether it's new legislation or modified legislation to allow this kind of stuff to go forward. So I find that really exciting to be part of that.
Yeah, that is really cool. So then I guess the outcome of this sort of area of your work would be to have, at least for this project, resource consent in place for doing mobile open ocean aquaculture, but then hopefully also to have other impacts on the legal frameworks around that.
Absolutely. That's the whole point of this program, is demonstrating a proof of concept, that we can actually have fish inside the enclosures that we've designed, and that we can test them and show that, yes, we have created the environment that we think we've created for these animals, and that they're going to be happy and they're going to be healthy and they're going to grow well inside them. And that was the whole scope of this program, was to be able to demonstrate that. But on top of that, another part of it was coming up with, and what we called it was like a regulatory toolbox, which provided options for people in Wellington to think about, well, how can the existing framework be modified, altered, changed to enable this type of not only research but potentially down the track commercial aquaculture to happen, because it's not just going to be us that are going to come up with these crazy ideas to do.
You'd hope not anyway.
Exactly. People will develop different types of technology overseas, and New Zealand will want to try out. And if there's no clear process to be able to do that, why would you invest? This is, sometimes where science can fall down is, you have a great program, it's really exciting, you get to the end and it just stops, because there's either no clear pathway to continue and implement, or the funding ends and there is no more, which is a real shame. But hopefully we can keep that pathway going. Well, that's the plan anyway.
Yeah, cool. And I guess that's partly driven by your own motivations, but would you also say that part of it is about your collaborators and who you work with on this project?
Yeah, so I had a bunch of really great collaborators here in New Zealand and also overseas, and the guys overseas are super keen to see things happen as well, because they almost see New Zealand as quite open to being able to trial these sorts of things, because overseas they equally have difficulty in being able to do this kind of research in the ocean as well. So it's we're not the only ones.
No.
Sometimes it feels like we are, but it's the collaborators are pretty cool. Oh, one thing I did forget to mention before is COVID did actually have quite a big impact on our research, because it was very much at the start of our program. We started this program in October 2019, and so COVID
a tough
hit,
time
and so
to start anything.
trying to find PhD students. We've got 3 PhD students in the program. That was quite challenging. Plus, we've never actually been able to travel to visit our collaborators. There's a number of our collaborators we've never met face to face, even though we meet with them every month, and so that's been a bit of a shame, but equally, we've still managed to get on with the research, and it's amazing, all the things that we've managed to do in spite of the restrictions that we've had. So
it's
interesting times.
It has been interesting times. I also have collaborators who I wrote grants with and started projects with before I ever met them in person.
Exactly.
And it's cool that we can do that, but it's also a little bit strange.
It's kind of sad, because you think, well, at the start you'd normally meet people and face-to-face and have a good conversation with them, and, you kind of get to know each other and then launch into these things. And, over the years, it's been, we're into our 4th year now of meeting every month with these guys. And it takes a wee while for that relationship to kind of get going and feel a bit more comfortable, but we've kind of got there in the end. And hopefully this year there's a conference that hopefully a number of us will meet up at, which will be really neat.
Nice.
Finally.
Yeah. So we've touched, I guess, on your international collaborators and relationships, but do you want to go into some of your partnerships with iwi as well?
Yeah, so within the program we have a Māori co-innovation group. The key role of that group has been to look at the opportunities, this type of technology development, so around mobile aquaculture, what type of opportunities does that raise for Māori? And so we've had quite a lot of engagement with different iwi, particularly here in Te Tauihu on the top of the south, wanting people to come in and be here right from the start and be involved with the development right from the start, rather than feeling like, oh, here's some people that have developed something and now they want our input. We've sought that right from the start of this program, which has been really enjoyable, I think, on both sides of being right at the grassroots of something right at the start. So that's been really exciting for me personally, in developing some of those relationships and learning a lot. I've learned a lot. I learn every time we have meetings, I learn something new, which is really cool. And with the resource consent, we've had to do a lot of engagement with iwi, a lot. And that's been a silver lining of doing the resource consent, is having that contact with iwi and getting down into the nitty-gritty of iwi's concerns about, being out in the environment. And it's been a really good experience for all of us, I think. And I'm really looking forward to the future of having that involvement with iwi and engagement with them with the research, because it's really enjoyable collaboration.
Are you able to go into some of the, I guess, favourite lessons or things you've taken out of this so far?
One enjoyable thing that came out of the resource consent discussions and with some of the iwi is just having that appreciation for the area that you're working with, like the area that we'll hopefully be testing our structures and fish at is up near Dervo Island. And so the iwi that whakapapa around, Dervo Island, it was great to hear that they're really excited about our research, but we're very excited to share their knowledge of the area and for us to understand how important that area is to them and why. And so that was really enjoyable. And we want to know more. We want to have more contact and understand even more, because we want to be working in their environment, and we must understand what area we're working in. It's super important to the research. So that's been really enjoyable.
That's good.
That's the aspect of it.
Yeah. It also sounds like it would be a really special experience to have people share that deep sort of importance of their place with you.
Absolute privilege to feel that people trust us enough to share that with us. So it's been really exciting, and trust us to be putting structures in the environment and that we're not going to harm the environment as well, because that's been a big thing as well, is that Well, you might be designing for the fish. It might be great for the fish, but what about everything else around them?
Yeah.
What about the rest of the environment that you're putting these structures into?
Yeah.
So it's like, so it's a good point.
It is. It's really important to have those considerations.
Yeah,
definitely.
absolutely.
So I guess now bringing it back to the fish, how do you go about finding the best structure for them?
So I guess right from the start is actually being able to cuddle up to your fish and get to know them a lot better. So that's a big part of the Nelson Finfish facility. So the whole reason we have that facility is to be able to do exactly that, cuddle up to the fish and get to know them. And that's been a big investment for Plant and Food over the years, because for any kind of seafood work, being able to get your hands on undamaged animals is a real game changer. It's not easy to do.
Yeah.
And, if you start working on degraded animals, your research doesn't really have that far to go. And so, there's been a lot of investment in being able to have populations of fish and different species of fish at our facility so we can carry out research on them. So, being able to have those species here. And then we've had some really talented PhD students come along and actually set up experiments where we can actually test and use fish's choice to actually, rather than just sticking them in a different flow and measuring how well they're swimming, we've actually set up experiments also to get them to choose which flows they like to swim in or what temperatures they like to swim in. There's also other different experiments you can carry out to not give them that choice, but just run them through different flows or different temperatures, and their physiology will tell you what's optimal. So, what's the flow that they will use the least amount of energy in? It's quite interesting, because a slow flow doesn't mean low energy output. Sometimes fish have to work harder in low flow to swim than they do if you speed it up a wee bit more. They don't have to use as much energy, but if you speed it up too much,
they get too tired.
It's too much.
And is that also because they need the flow of water over their gills? Or?
And just the way that their locomotion, their type of locomotion, sometimes they need that flow to help with locomotion and lift. And so sometimes if it's too slow, they have to work harder than if it's a little bit faster. So there's interesting experiments like that to carry out, and thinking about the choice versus optima. Do they overlap? Like where they like to be versus where they grow best, or things like that.
Yeah, I like to be on the sofa, but that's not always best for me.
Is that the best for you? Yeah, that's precisely it. And so the PhD students are just sort of grappling with that at the moment, is do they overlap, or is there some separation there?
Those are some really cool questions.
Yeah, there's some really cool questions. But and also thinking about, we're doing Chinook salmon and New Zealand snapper in this project, but that's not to say they're the best species for being out in the open ocean.
Yeah.
They may not be, but they're a starting point for us. We think that probably Chinook salmon will be, because we know overseas, Atlantic salmon, there's a lot of open ocean aquaculture happening out there. We've got some amazing species in New Zealand. There may be other species that are better suited for the open ocean environment than snapper might be. Snapper might be great. We don't know yet, because we haven't gotten out there. But that's another thing around mobile aquaculture. It actually opens up opportunity for species diversity. So in New Zealand, Chinook salmon is pretty much the only species we aquaculture out in the sea.
Yeah.
And so getting away from that stuck in one place issue, if we can move around and be in the best temperatures, that does open up opportunity for different species to be assessed for their aquaculture ability, if you like. So there's potential down the track for new species of fish to be aquacultured. So who knows what species we'll see. Hopefully kingfish will be developed even further than it is now. Kingfish may be great. Trevally may be great. A number of the waraho species might be fantastic as well. Who knows?
Maybe your blue cod that you like to eat.
Maybe my blue cod, they're maybe not in the open ocean because they like being down on the bottom, but who knows?
Yeah.
But there might be other systems that people come up with that are great for blue cod. Who knows?
Lots of opportunities.
Absolutely.
Then. Yeah. And what about, the structure itself? How do you know that it's going to be suitable for being in the ocean, because the ocean's a pretty crazy place sometimes?
Yeah, so one good thing about that is that we've been able to test the physical side of things with these structures. So since the start of the program, we've managed to get resource consent to have a number of test moorings out in Tasman Bay that we can create the fish enclosures and take them out and test them on the moorings. run them through some storm events, have them out there, make sure that they are going to be strong enough, they're going to hold together for when we actually have fish in them. So we've been able to do that. So we've been able to have them out there, we've been able to measure flow inside and out of these structures and understand how they move with the current, how they move with the change of tide. And various things like that. So we've been able to do a lot of that kind of testing in the interim, while we've been waiting to be able to put fish inside them. So that's been a big part of the program, because no one wants to put fish in a structure that's going to break up in bad weather.
Cool. Is there also like quite a bit of computer modelling involved in that?
Yeah, there is.
Well?
It's sort of partway through the program, one of our young engineers joined us, and he's an expert in modelling. And so that's been a really great asset for the program, is being able to try a whole bunch of different shapes, sizes, additions to our basic geometries. And so he's been able to run through a whole bunch of different scenarios that you'd never be able to do with a structure out in the water. And so that's thrown up all sorts of interesting things. And you can try out all sorts of things and not worrying about, well, how do you physically make that? You get to actually be quite creative and try and solve other problems before you get to the problem of, well, how do you actually physically make that? So that's been really a great part of the program as well. So taking it, that's that whole series of how this the kind of prototype iteration process has happened, is coming up with these ideas, being able to model them, to sort of do that desktop modelling before you go to a small scale model. We now have our flume tank, which has been fantastic, but at the start of the program we didn't have our flume tank, so we tested things in rivers and swimming pools and things like that.
You got to work with what you've
haven't
got
got a flume tank, you try other things.
Yeah.
And so you go from that small scale modelling, and then we've stepped up from there to a bigger model that we can actually put out in the sea and test on those moorings. And then the next step is to take that same size model and put fish in it out on where we were trying to get consent for trials. And then from there, if that's looking good, we step up again to a much larger scale prototype. Quite a process.
Yeah. Do you link up any of the computer modelling with environmental databases? For example, you have a sample site out at sea where you might be interested to put something. Do you sort of link those two up, or do you just sort of pick variables? So
during the program we linked up with MPI and had a data cube created for around New Zealand for all that mid-ocean data, temperatures, flows, all the rest of it, swells. And some of the collaborators we've been working with, particularly Ross Fenwick at the Cawthron, but also our collaborators over at Exeter University, have taken that mid-ocean data and done a lot of that modelling about, okay, well, what's the the significant wave height that we're going to meet there? What's the the 10-year maximum wave height that we might experience out there, and being able to design for those extreme weather events. Because we might luck it and never have a huge storm event out there while we're testing, but we might, and so we have to design for that. So also, collaborators up at Sintef in Norway who have huge experience in this area as well. They're the smarty pantses and the big brains to be able to put all that together for us. It's a big part of the puzzle. And so, another part of it is, although the testing that we'll be doing won't be mobile, it'll be on a single point mooring. Mm-hmm. The fish enclosure will be attached to a single point mooring, and we'll swing around the mooring with the tide. If we look out, maybe 30 years' time, things will be entirely mobile. Our collaborators at Exeter have been looking at that kind of scenario and looking at the management scenarios of how that could happen. So looking at that mid-ocean data and thinking about energy on board and thinking how far can we actually move this thing before we need to get back to a safe area for whether it's refuelling or whether there's just a big storm event coming, and understanding all those scenarios, weather scenarios, feed on board, and understanding how that can all be optimised for the different aquaculture scenarios. So that's been, that's been pretty interesting.
Yeah, it all sounds a bit mind-blowing.
Oh, totally, yeah.
And I guess there's also a lot of other aspects of looking after fish. So you don't just need the structure, and you don't just need the fish out there, but you need to feed them, and you need to keep an eye on them to make sure they're doing okay. And then I guess eventually you need to think about, like you said, moving them. How does all of that kind of work?
So that's over the last, 30 years that I've been here, it's not just my experience, but all the other people that have been here and all the people that have been here before me, is taking that experience of aquaculture and understanding fish husbandry and understanding that, and how that knowledge, how that can be packaged up to then be able to remotely understand your fish. And so you've got smart people here like David Ashton that can have images, live images running back from these enclosures and be able to understand, well, look at the fish behaviour or the swimming speed and know, yes, that fish is happy and it's healthy and it's growing really well. Or conversely, if it doesn't look great, understanding that and trying to understand why, and then being able to modify the environment to improve the conditions for the fish. But yeah, we're spending a lot of time working out, well, okay, we've got this enclosure out there, but how do you feed fish in there? And this is, I keep reminding people, this is research. We don't have all the answers right now.
Yeah.
We're coming up with concepts that we'll be trying out. But yeah, very much proof of concept. We've got some pretty awesome ideas and got some pretty amazing people working there on these exact tasks that you've just described. And, one of the big ones is just having consistent communications back from the fish enclosure, and that's not an easy thing.
No, it wouldn't be.
It's just really been in the last couple of years that the sort of technology has become available and cost effective for us to be able to do that. And that's a huge part of this type of technology being able to work in the future, is having that really reliable comms back from over the horizon, basically.
Yeah.
So
Yeah,
because you know that your fish are okay.
Yeah. Yeah, I guess you wouldn't want to rely too much on staff, like going out there all the time, especially not in all conditions.
And that was a big design element of the original concept, is getting people out of dangerous situations. So, progressing out into the open ocean, but trying to get people out of that dangerous environment. The whole idea was to have an unmanned aquaculture system that you can view from on land, that you can control from on land, but it's not requiring humans to be out there putting their lives at risk in a dangerous environment.
So I guess we don't all have to be scared of robots taking our jobs, because sometimes they can do good things for us.
Exactly.
Yeah.
So the balance
it is
of being able to do that.
Yeah. So in your sort of dream open ocean aquaculture system of the future, are there also like support vessels involved, or how does
Absolutely.
that
So
all fit together?
the original concept was to, I think we called them swarms of these, we'd have a fish enclosure, but that's connected to a moving unmanned service vehicle that contains all the feed, and with an umbilical that goes down to the fish enclosure. It's got all the monitoring systems on board, it knows, it can see the fish, the dissolved oxygen's monitored, all the rest of it to make sure the fish are happy. But then have a service vessel that potentially comes out every couple of weeks or so that can refill for feed, and depending on the energy system, replenish, whatever that's going to be. Yeah, and so that, okay, the service ship may come out and there'll be people on that, but any maintenance would be done back on land. So you either swap in and out service vessels, or the smaller service vessels for the fish enclosures, and so that the most people involvement still happens back on land. So yeah.
Cool. Sounds like a little fish utopia that you're making.
Yeah, absolutely. yeah. But it's trying to keep the fish in the water and sort of, minimise handling.
Yeah.
Being able to, if we had a system where we could, individually identify fish and know that, individual growth rates and all that kind of stuff, it means that you can reduce manual handling of fish down to a minimum, so that they're in their environment for the longest possible time.
Cool. I guess the less utopian part of this is what happens at like harvest time for the fish and the enclosures. How would that happen?
Well, I guess our group has got that experience with aquatic fish anaesthetics, so it's not a kind of a closed book kind of thing of, oh gosh, how do we do that?
Yeah.
We have a lot of experience in harvesting animals, whether it's through wild capture fisheries or through aquaculture. So yeah, although that's not within the scope of this program, we certainly have ideas on how that could happen.
Yeah.
And it's not a far cry to think, well, do you have to bring these fish all back onto land? Could you actually harvest them and process them on board another vessel at sea, and then they carry on to their destination for consumption? Who knows?
Yeah.
But there's a lot of options available.
Yeah, I guess a lot of fish processing happens on fishing boats nowadays anyway, so it's not a big difference.
Not
there.
a big leap to think that could also happen.
Yeah. Cool. Maybe we haven't touched so much on the main advantages of going into like a mobile open ocean as opposed to land-based or what the current systems are.
I guess where we saw a mobile type of aquaculture being really beneficial was just purely being able to open up production area. And so New Zealand's got a huge EEZ. Are we able to utilise even a fraction of it for seafood production? It's very difficult to say that about putting, fish onto land. Yes, it's not to say that, there aren't viable options for doing that, but we also have the ability to go out beyond our coastal areas, and that's another bonus we see of this is, that the coastal area is so hotly contended by so many different groups. Not only, the recreational fishers and the public, you've got commercial fishing, you've got, just commercial vessels, any commercial vessel using that side of things, plus all the environmental impacts of the coastal community. So being able to move away from that into deeper water, and yes, the environmental impacts are less if you're not stuck in one place. Your benthic deposition, so putting any waste onto the sea floor, you've got if you're completely mobile, you're moving around all the time, so you're not depositing in the same place over and over again. You've got a much greater volume of seawater, and you've got sea currents carrying things away, so that environmental impact is considerably less.
Those sound like really good reasons to get into that, on top of keeping the fish happy.
Exactly.
Yeah.
So there's it's an opportunity. But as I sort of keep stressing to people, this project is a proof of concept. It's not going to answer all the questions. There's so many questions, more questions to answer. The more you look, the more there is to answer.
Yeah.
But our job as scientists is to be able to show people what's possible, and then come together with people to come up with, okay, well, what are all the tools that we need to make this happen and turn it into a reality, not just a demonstration, but turn it into a reality. So that's a big part of the whole picture.
Yeah. Do you want to finish on maybe something that you're most excited about for the future of open ocean aquaculture?
I've got such a immediate focus at the moment of I cannot wait for us to get fish into one of our enclosures. I'm super excited about doing that. I know technically we can do it. We've got a fabulous team of people that I know can do it. So I'm really excited for that, and I know they're excited to do it. So for me, that's a super exciting thing to do. Beyond the program, I would love to see this program progress and for us to do more trials. But also, if we can move things, one step closer to be able to enable this type of aquaculture to happen, it might not be us that does it in the end. It might be somebody else. But if this program can be the start of that ball rolling, that'd make me super, super happy. Yeah.
Cool. Well, I look forward to the day we get fish in those enclosures, and that'll be really cool.
Thanks, Julie.
Yeah. And thank you so much out there for tuning into Sigest today, and I hope you found this conversation as interesting as I did. If you'd like to learn more about our star scientists or this particular episode, feel free to visit the Sigest website, and don't forget to subscribe and leave a review on your favorite podcast provider.